link to today's lessons, and I will put it in the chat so that you can copy and paste it if you like. We will use the lessons that are in that link when we do exercises today, so please have that open in a browser. And then I'm also going to have one more link I want you to have open. This is the command history. So similar to yesterday, we will have a history of all the commands that I enter in the command line. It will show up to 10 seconds later, because there's a 10-second refresh on this page in the command history. So if you missed something or you want to copy and paste a command that I entered that was a little bit longer, you can do that by just having that browser window open and checking it, or scrolling up if you missed something you'd like to see it again. Just be aware that that link is different than yesterday's link. If you were here yesterday, because it's the date, it's today's date instead of yesterday's date. So it's the 14th rather than the 13th. Okay, everybody should be logged in by now to Crane. If you're not logged in, please do so. This slide deck I have here is the same as I used yesterday, but I'm not going to be presenting all the slides because I already did that yesterday. I just have one or two that I'll go over one more time. So this is what it looks like when you log in. On the left is what it looks like if you're logging into a terminal, like from a Mac or a newer Windows 10. And on the right is what it would look like if you were logging in through PuTTY. So you should have already done this by now, but that's kind of what it looks like. And I will do an example in just a second of logging in with a Mac. So I'll do the terminal version. So welcome everybody. My name is Emily. I'm going to be presenting today's lesson, which is a continuation of yesterday's Bash lessons. They typically take, 4 hours or more even. So this time we divided it up into two-hour lessons. And I hope that we can get through all of them today. We have a few helpers with us who are going to be answering any questions that you might have and monitoring the chat to see what people are saying and making sure that everybody stays caught up. So thank you to the helpers as well. Okay, I talked about this slide yesterday, but here are a few links that might be helpful for you, especially if you didn't attend yesterday. This is our HCC website, our documentation page, and also our support email. If you find that you are not finding what you're looking for on our docs page and you still have questions, then please feel free to email us at that email address. And we're going to be talking about the items in this slide on Wednesday. So what sort of services that we as Holland Computing Center provide to the University of Nebraska systems, and the details of how to access those and how to get started on our clusters. This is the agenda. It's just directly from the workshop website. So today we are continuing, like I said, with the Bash lessons from yesterday. We will learn about how to write a loop, how to write a shell script, and how to find things in your text files, and how to find particular files and directories in your directory tree. I talked about this stuff yesterday, so I won't go over it again. This is what I just said, basically. So this is an outline of all of the shell lessons. Yesterday we covered the first 4, and today we're going to try to get through the last 3, which are slightly more advanced, so they might take a little bit more time, but I hope that we can get through all of them, including most of the exercises. So like I said, loops. This is just a way to execute commands multiple times for each item in a list. Shell scripts are a way of saving our workflow in just a text file so that we can execute that multiple times. And finding things is a way to look for text in our files, and also finding particular files and directories that might be buried somewhere in our directory tree and we can't remember where we put them. So definitely useful information to know if you're working in the Unix shell. Once again, this is kind of a little cheat sheet of the commands. Most of the commands, or the most useful commands that we're going to be using for these lessons, but feel free to Google cheat sheets of your own. I'm sure there's better ones out there online. And we're going to go ahead and just get started with the lessons. So like I said, please log into Crane. I'm going to show how that's done in just a second, if you haven't done it before. And then these are the links that I asked you to have open already. So here they are again, same ones that I put in the chat. So if you still haven't opened those, please do so. Okay, great. I'm going to share my entire desktop now. So just give me 1 second to get that set up. Okay, you guys should now be seeing my entire desktop. I'm going to just show the windows. I have on the right here my my terminal that's open. I'm already logged in with this terminal, but I have another one open that I can show you just the login process. The command is ssh demo 01 for my username. You would put your username here at crane.unl.edu. Enter your password, and then 1 for dual push. And then I'll get a notification to my phone, and I just open that up and press approve, and then I'll be logged in. Okay. I'm already logged in over here, which is the window that I actually want to use today, because this is the window that is recording my command history for you guys. So you can check that out on the link that I shared. Here's the browser windows that I'd like you to have open. So this is the link to our lessons, and we'll be using this for exercises. We're going to be doing 5, 6, and 7 today. So if you want to go ahead and open up number 5, the loops lesson. And then I'd like you to also have open the software or the command history window here. So you can see that I already entered a couple commands earlier today, clear and ls. And so those show up here. Okay, so let's go ahead and get started. I'm going to clear my screen again. Let me know if that text is too small. I can increase the size if I need to. Okay. All right, so like I said, I'm going to actually first show how to download the data set that we use for these lessons. In case you were not here yesterday, I'm going to do that one more time. So to download the data, we use wget, and I'm going to enter this command, and it will show up in the command history, so you can copy and paste it from there if you want. Most of our commands you will not have to copy and paste because they're short, but this one's a little longer, and so if you want to avoid any typos in this URL, that's one way to do it. Okay, so it's just the URL of this zip file that we want to download. Hopefully I didn't put any typos in there. We'll find out. Okay, it looks like it downloaded 100%. It says no errors. So if I type ls, I see that now I have this zip file. If you already have the zip file there, it will tell it'll either copy over it or tell you that it's already there. So you don't need to do this if you already have downloaded this in your home directory from yesterday. Now I'll unzip it. So you don't need to do this if you already unzipped it yesterday. So just hang tight for a second if you already did this yesterday. Okay, now I do -Q, so it's quiet. That way it won't list all of the files and directories as it unzips it, because that's a little bit too much to show on the screen right now. If I type ls again, I see that I now have a new directory called shell lesson data. And that's what we're going to be using for the lessons. Okay, so if you recall from yesterday, we talked about how to move around in our directory tree using CD to change directories, how to make new files using the touch command, how to make directories using makedir, how to change the name of directories using MV for move, how to move files and directories using that same command, copy things using the CP command, and remove things using RM. So we also talked about pipes and filters. So pipe is just filter is just a program. So like the word count program that we used yesterday to count the words, lines, and characters in a file. And pipe is just something that pipes the output from one program into the input of another program. So that's just, if you weren't around yesterday, please feel free to use those software carpentry lessons on the link I provided and go through those lessons at some later date when you have a chance, because they're really good introductory lessons that you might find helpful to have completed for today's lessons. But yeah, if you don't have a chance, if you've not done them before, just try to get to them at some later date. Okay, so today we're going to talk about loops. So this is one way of automating tasks in the shell when a single command or a combination of pipes and filters really isn't enough to do what you want to do. We're going to learn how to put those commands into a loop. So let's first CD into the shell lesson data directory. So CD, I'm going to just say I want to go in my home directory. In case I'm not located currently in my home directory, I just include that so it knows where the shell lesson data is located. And then pwd shows that I'm now in my home directory, and within that, I'm in the subdirectory shell lesson data. Okay, so as you may remember from yesterday, these files are meant to sort of simulate the directories of a researcher named Nellie. If I type ls, I see that she's got several different files and directories within this. We're going to be using the creatures directory next. So let's cd into creatures. You can use tab completion to finish that for you if you type just the first few characters. If I type ls again, I see that there's a few different .dat files in here. And what we want to do with this next task is rename the files and change them all. So instead of basilisk.dat and minotaur and unicorn.dat, there's a prefix at the beginning of each file name. So basilisk.dat should be changed to original-basilisk.dat. And I'm not going to press enter because I don't want to do this for each file one by one, because if you could imagine only having to do this 3 times is fine. But if there were hundreds of files in here, I would want a programmatic way to complete this task. So, but that's what we want to do. We want to do that for each of the files. You might naively guess that, oh, maybe one way to do this is move star.dat original star.dat. Right, but that's not going to work because the shell is going to try to expand this and try to find a file that starts with original, and it's going to give us an error. So I can try it, but it says no, that's not a thing. Okay, so instead we're going to write a loop to do this. What a loop does is that for each iteration of the loop, it does some operation once for each item in the list that we provide. So let's just try a test loop to see how this works. So for is a keyword, and that it's a special word that means we are beginning our loop. So when shell sees the word for, it knows that we're starting a loop. So file name is just a variable. I can make this file name, or I can make it X, or I can make it whatever variable I want. It makes sense to use variables that make sense to you, though, that have some meaning so that you know what it's supposed to represent. In is another keyword. It means that we are going to provide a list of items that the file name variable should be assigned to. So for this example, we're just going to type out each file name, but for subsequent examples, I'll show how to do it just using the wildcard characters so that you don't have to type out each one, which obviously will be helpful if you have more than 3 in here. Okay, so after this, after I finish my list of items, I press enter. And then you see the little greater than symbol. That means it's waiting for you to start your loop. So I type do. Do is a keyword, and it means we are going to begin our instruction set. So what do I want it to do for each item in this list? What I want it to do for this example is give me the first 2 lines of the file, and then pipe that into the tail command and grab the last one of those, right? So let's look at this line for just a second here. We learned about the head and tail commands yesterday. So first of all, file name is different for each iteration of our loop. For the first iteration, file name is assigned to basilisk ... And when I assign it here, I don't put the $sign in front of it, but when I refer to it here, I do put the $sign in front of it so that the shell knows it's a variable and it needs to replace that variable with the actual value of the variable. So the value in this case for the first iteration is basilisk ... So head-n2 basilisk ... will give me the first 2 lines of that file. If I pipe that into the tail command and have it grab the last line, the last 1 line, what my end result is going to be is just the second line of that file. So it's going to print the second line of basilisk ... and then the second line of minotaur ... and so on. Okay, so that's what I want it to do, and I'm done. So I type done. That means my instruction set has ended, and I want it to execute what's in the loop. So I press enter, and that's the output. So this is the second line of basilisk ... This is the second line of minotaur ... and this is the second line of unicorn ... Okay. Does that structure make sense to everybody? Are there any questions about that? Okay. So before we move on, we're going to learn a new helpful command here, and that's the echo command. So if I type echo hello there, the echo command is just going to print to the screen whatever arguments I give it. So the arguments are hello there, and it's just going to print that as output. So it just prints hello there. I could also do echo star.dat, and that will look for anything that ends in .dat in my current directory and print those file names to the screen, right? Okay, so let's use this in a new loop. I'm going to clear my screen and go all the way up to the top so it's a little bit more readable. Okay, so for file name in, I'm going to give it a list using the wildcard so I don't have to type each file name out. Do. Okay, and now here's where I start my instructions. Instead of just having it do one thing, one line, I'm going to have 2 lines in my loop. So first I'm going to have it echo the file name. Right, and I press enter, and I'm not going to type done this time. I'm going to enter my second instruction, my second line. Oops, head-n100 file name. Pipe that into tail-n20. Okay, so instead of the second line of the file, this is going to take the first 100 lines and then the last 20 of those. So the end result is that it will print out lines 81 through 100 of the file. Okay, so first, if you scroll up, this is the output. So the first thing it did was echoed the file name, like I asked it to, and then it showed lines 81 through 100. Then it went to the second iteration of the loop and echoed the file name and lines 81 through 100, and so on. Okay. Did anybody have a problem getting that loop to execute correctly? Great. Okay, so File name expansion in loops is one reason that we don't want to put spaces in our file names. So you could imagine if I'm going to scroll up, if there was a space in this file name, if I had a space in one of my file names, this would say head-n100, and then it would, let's say my file name was red dragon ... with a space in there. It would say head-n100 red space dragon ... So that would be interpreting that as two different files, and it wouldn't work, obviously. So sometimes we will put that into quotes. So to avoid that, in case there are any spaces or strange things in your file names, we can put this expression, the $file name, into double quotes, and then it will avoid any strange things from occurring. So you might see that in later examples. We'll go ahead and just put it into quotes. Okay, any questions so far? All right, so let's go back to original problem. We wanted to rename all the files with that original prefix. So let's try to do that now in a loop. I'm going to clear the screen again. All right. So another thing that I might do is when I'm writing a loop, especially if I'm using the move command like I'm going to do next, I might actually, instead of executing the loop as is, what I might do is do an echo before my command, before the move command that I want to use. And that way this loop will not actually execute the move command. It will just print it out to the screen. And the reason for that is that move can be a dangerous command because you can actually accidentally overwrite things that already exist if you do it incorrectly. So if I have a typo or I've just made a mistake, it's something that I want to just double check before I actually execute the loop. So I'm going to have it, what I want it to do is move file name, and move, of course, will rename it instead of move it if I give it a new file name. Okay, so that's what I want to do, but I just want to print that command to the screen instead of actually executing it, and that's why I've put the echo in front. Okay, so let's type done and enter. Okay, so now I see what will happen if I take the echo out and I just have it execute these commands. And those commands look correct to me. So I'm going to just use the up arrow to go back to that loop that I just executed. And as you can see, it puts it all in one line for me. And that's okay. But I'm going to just scroll back and remove that echo. I'm just deleting the echo, and then I press enter. There's nothing printed to the screen, but if I do ls now, I can see that all my files have been correctly renamed. How are people doing with that? Everyone okay so far? Okay, so our researcher Nellie has some files to process in the North Pacific Gyre 2012-0703 directory, which we were working in somewhat yesterday. So let's go ahead and cd into that cd into that directory. So I'm going to go up one level. ... stands for the directory containing this one. So up one level and then down into the North Pacific Gyre 2012-0703. And you can use tab completion here. So type NOR tab and it should complete it for you. And then just a 2 is enough to complete that for you because there's no other directories in that directory. And then enter. If I type pwd, this is where I am now. So everybody should try to make sure that they're in the same directory as me. Of course, your home directory will be different though. Okay, so I'm going to type ls. Just like yesterday, you see a bunch of text files in here. These are the data files that we want to analyze. There's a couple programs. These are shell scripts. And we'll learn about shell scripts in the next lesson. So, but typically they end in .sh just by convention. So you know that that's a shell script. And then let's see. What she wants to do is run one of these programs. She wants to run goostats, the shell script, and using the input files here. And she wants to run it once for each of the input files here. Okay, so to do that for one input file is simple, right? You just type it. You type bash. That's the program we want to use to execute our shell script. Goostats.sh. The name of the input file. So I'll just select one of these. And then she needs to provide to the goostats program is expecting an output file name as well. So she wants the output file to be just the name of the input file, but with a prefix stats dash. Okay. I'm not going to press enter here. I'm just showing you how she would execute it for each of these files. But she doesn't want to enter this by hand for each file in here, so she's going to do it in a loop. So we're going to do it in a loop. Okay. Just delete that. All right, so let's write our loop. This time we'll just use data file instead of file name, just to show that you can use any variable. All right, so we're going to provide our list. So for data file in NENE star, and then do you remember from yesterday, we only wanted to use file names that ended in A or B.txt because the ones that end in Z were problematic. Okay, so that's our list of items. That's our list of files. We start with do. And then I'm going to put echo in front like we did before, just in case I make a mistake here. Okay, so this is what I want the command to be. Bash goostats.sh. Data file is the input file, and then stats-data file is the output file. So if I type done and enter, I see what all the commands to analyze each of these files will be. If I want to actually do the analysis, let's do one more thing, actually. I'm going to rewrite this loop and have it do an echo command so that we can see its progress as it does the analysis. Okay, so just the same as before, for data file in any star A or B.txt, do. And then instead of just having it run the analysis, I'm going to have it echo the data file name so that as it progresses through the loop, I can see it, which one it's on. So how far it's progressed through the loop as it goes. All right, and then I'm just going to go ahead and copy and paste this from my last one without the echo command. Okay, so this time it's going to actually do the analysis. Okay, so I pressed done and then enter, and now it's going through each of the text files and analyzing them and creating an output file, hopefully. Okay, so if you've completed this and got it to run through this loop, can you please put the green check mark by your name in the Zoom participants or reactions panel? I'll just wait a minute. Or if you couldn't get it to run, type your question in or unmute yourself and ask ask your question. Or ask me to repeat something. So one thing I just wanted to show though is we can check, let's go ahead and check if the output was produced. I'm going to type ls and see. Okay, so it looks like all the output files with the prefix stats were created, so that's great. We can do a little sanity check here and just see that the number of input files matches the number of output files. So I'm going to use the ls with the word count command. Right, so this is going to list all the files that, all of the input files I used, and then I'm going to use the pipe command to pipe it in the word count command to see how many there are at a glance. So there's 15 input files, and then I'm going to use the up arrow to go back to my previous command and just change this, stats -NENE, and this will count the number of output files that were created. So let's make sure they're the same. So I have 15 input and 15 output files. So that's just a good way to just run a quick sanity check to make sure you have the same number and everything ran correctly. Another helpful command is the history command. So if I type history, it will show me the last like 500 or so commands that I entered. If I just want like the last 5 of those, let's say, I can pipe that into the tail command. Let's say I just want the last 5, right? So it just shows me the last 5 commands with a number in front of each one. So if I want to re-enter one of my previous commands, let's say I want to re-enter this one, I can use the bang operator, which is just the exclamation mark, followed by the number. So 1035, for example. And it will re-execute that command. That can be helpful if the up and down arrows help you get back to previous commands, but it also helps. Sometimes I know I entered something many commands ago, so what I do is I type history, and I know that I used, I used the word count command or something like that. So we'll learn about grep later, but grep will search for text. So if I want to search for, let's say I want to search for stats, then I can show all the commands that I executed that had stats somewhere in that command, right? So grep we'll learn about later, so don't worry about that too much. But I'm just wanted to show how history can be useful to find previous things that you've entered. All right. I'm going to open up the lesson link that I showed you before. So this is the loops lesson. Please go ahead and just go through all the exercises that you have time for. The exercises, just like before, just like yesterday, they all start with a little pencil icon. So scroll down until you see the first one, which is called variables in loops, and just continue until you've completed as many as you have time for. There's quite a few, so we'll just go ahead and work on this for the next 9 or 10 minutes, and then we'll reconvene and start on the next lesson and answer any questions that you might have about the lessons, about the exercises. So. All right, welcome back, everyone. We're going to go ahead and start in on the next lesson, which is shell scripts. So if you have the link to the lessons open in a browser, you can go back and click on the number 6 shell scripts lesson. I will put that in the chat. The direct link to that is in the chat now, so you could open it from there. And we'll use this when we do the exercises for this lesson. So if we have a set of commands that we want to run repeatedly, we can just save those commands in a file and then tell the shell to execute the commands that are in the file. And this is just called a shell script. And it's basically just a file that contains a bunch of shell commands that we want to run in order. So we're going to cd into a different directory for this lesson. I'm going to clear my screen now and see where I am. I'm in North Pacific jar 2012-0703. let's go back up. One way to do it is to go back up 2 levels, back to the shell lesson data directory, and type ls. And I want to be in the molecules directory now. CD molecules. Okay. Another way to get to that directory would be to cd tilde, which stands for home, shell lesson data molecules. And you can run this from anywhere. And it should take you to the correct directory as long as shell lesson data is in your home directory. Okay. So let's do ls. We have the PDB files that stand for protein data bank files in this directory. So let's go ahead and create our first shell script to do something with these files. We are going to edit it using nano like we did yesterday. So nano is the command, and we want to create a file and edit the file that's called middle.sh. If this file doesn't exist already, which it does not, it will create the file and open it for us. So the command is nano middle.sh. If I press enter, it opens up this editor for us. And I can just put the lines that I want my shell script to execute in this file. So what I want it to do is give me the first 15 lines of octane.pdb, and then pipe that into the tail command. So grab the last 5 of those. So this result will print out the lines 11 through 15 of octane.pdb. Okay, so this is just one command. You could put more in here, but we're just going to start with this one, see how to call this script. So we can save it with a Control-O and then enter, and then exit with Control-X. I'll do that again real quick, just so that anyone who missed it. So nano middle.sh, enter. We put this line in there. Head-N15, octane.pdb, pipe is the vertical bar, and then tail-N5. To save, I do Control-O, hold down the Control button and press O, and then it asks me the file name, I press enter, and then Control-X will exit, okay? So let's run the program. Like before with the goosestats program, if you recall, we type bash and then the name of the program, or the name of the shell script. Bash middle.sh. Okay, so that did print lines 11 through 15 of octane.pdb. So what if we want to print the lines from an arbitrary file without editing the middle.sh script every time that we change it? Change that file name. So we can use a special variable for this. So let's do nano middle.sh again and make a change. So here, instead of octane.pdb, I use, and I put it in quotes, $1. The quotes are in case there's any spaces in the file name or something like that. So $1 is a special variable, and what it means is replace this. The script should replace the $1 with the first argument that we give this program on the command line when we execute it. So $1 stands for the first argument. So I will run it, and then you will see how that works. So let's save it first. Control-O to save, enter, and then Control-X. Okay, so now when I run this program, it needs an argument to put in instead of $1. So I do a space after, oh, I'm sorry, not nano. I want to run the program. So I'm typing bash middle.sh, and then I give it an argument that is the file name it should replace the $1 with. Okay, let's use octane.pdb again. Okay, so this time it did exactly the same thing as before, but we implemented it slightly differently. Okay, We could also run it with a different file. So without actually changing the shell script, we can have it print lines 11 through 15 of a different file. All right, so that's much more convenient. All right, what if now we want to be able to adjust the range of lines that we print out? So instead of 11 through 15, I want to print out a different range without editing the file each time. So let's make another change. So open up middle.sh using the nano command. Okay, so I want this 15 to be something that I can decide when I execute the program. So it's not hard written into the program itself. So I'm going to use another special variable, and it's just $2. And that stands for the second argument. So $1 is the first argument, and $2 is the second argument. And same with the 5 here. I want to replace that with the third argument. Oops, quotes. Okay. So now I can specify the file name as well as the range. So Control O to save that, Enter, and then Control X. Okay, so now we need 3 arguments when we run this program. We can use the same ones we did before, so 15 for the head command and 5 for the tail command to print lines 11 through 15, or we can use different numbers. I'm using the up arrow to go back to my previous command. Let's say I wanted lines 16 through 20. I could do it like that. All right, does that make sense? So this program, middle.sh, has become much more convenient and modular and useful. Okay, so that's a nice program, but if we take a look at it again, nano middle.sh, it's a bit cryptic. Let's definitely add some comments here. I'm going to put some comments at the top. Anything that starts with this pound sign will be interpreted as a comment, so the shell will not execute this. So it's a good practice to comment your code so that when you look at it later, a year later, whenever you pull it out again, or if somebody else uses it, they'll know what it does and how to use it. Okay, so this is how to use the file. So how to use the program. Actually, it's bash. So you type bash middle.sh, you give it the file name, the end line, and the number of lines to print. Okay. Control O, Enter, and then Control X. Okay. So for our next example, what if we don't know how many input arguments there's going to be? So for example, I want to put this command or something like this command. Let's clear the screen first real quick. I want to put something like this into my script. So right, so what I want my script to do is to count the number of lines in a bunch of files that I give it on the command line when I execute the script, but I don't know how many of those ahead of time there's going to be. And then I want to sort that. So that's what I want to put in there. So let's go ahead and try that. Let's create a new shell script called sorted.sh. Okay, word count -L. Okay, so now here's where I would put the list of files that I want it to count the lines in. But I'm going to provide those files on the command line when I call this program. So instead, I need to use my special variables, right? So I would have $1, $2, etc. But I don't know how many there's going to be. So I don't know how many special variables to use here. So instead, there's another special variable that's the $@ and, or at, I'm sorry, the at symbol. And what that stands for is all of the command line arguments that we provide when we call the shell script. So all of them will be put there. And that's exactly what I want. Right, and then I want it to pipe that into the sort command so that I can sort the files by the number of lines that they contain. And let's go ahead and put a comment in here right now while we're thinking of it. Sort, what this does is it sorts files by their length. And the usage is bash sorted.sh, and then one or more file names. Right? So multiple arguments, file name arguments can be given to this shell script. Okay, let's go ahead and try it out. So save is Control O, and then Control X. Okay, let's run it. So bash sorted.sh. So star.pdb. Okay, that's how we provide all of those input arguments. This, before it runs sorted.sh, this will expand and it's the same as just typing out each of those file names right here after the name of the shell script separated by spaces. So that's exactly what it would be. Okay, so it counts the number of lines and sorts it just how we wanted it. We could also include other file names here. So let's say I wanted it to count not only the lines in all of the PDB files in the current directory, but let's say I wanted it to look in the creatures directory as well, which is, we have to say it's one level up from where we are and then down into the creatures directory. And I want it to look at all of the .dat files that are in there. And it sorts those as well. Counts the lines and sorts all of those files. Okay, so it's just definitely more versatile if we can provide the variables on the command line instead of hard coding them into our script every time. So let's go back to Nellie's data analysis problem, the GooStats program that she needs to run. She decides to write a script to run her GooStats program because the results need to be reproducible. So she wants to be able to rerun the script later and make sure that she gets the same results each time. So I'm going to cd back into that directory. So it's up one level and then down into North Pacific Gyre 2012-0703. Everyone should be here now. Another way to get there is cd /shell lesson data North Pacific Gyre and then 2012-0703. That will take you to the same place. Okay, so let's write, type ls, you see the same stuff we saw before, all of those text files and all of our stats output files that we created earlier. So I'm going to write a new shell script called dostats.sh. Okay, let's put a comment in here already. Calculate stats for data files. So I'm also going to put a loop in here. So for data file, if you recall, she analyzed her data in a loop in, and then we're going to use that special variable that stands for all of the input arguments because we want to loop through each of those files. And it's nice to use like tabs to show that you're inside of a loop. So I'm going to use a tab here to indent. So first I'm going to echo the data file name, and then I'm going to run the program. Just like I did before. Now all of these stats data file output files already exist in this directory. So when I run this, it will just write over them. That's okay. Okay, so that's our loop. That's the same loop we had before, essentially. I'm going to save this. Control O. The name of the file is do-stats.sh. And then Control X to quit. And let's go ahead and try running it. So it's bash do-stats.sh. And then we needed to give it a list of files. So it's NENE star A or B dot text. Okay. And here we go. Was everybody able to create this do-stats.sh file and execute it? Put a green check mark by your name in the participants or the reactions panel on Zoom if you were able to do this successfully. And go ahead, and if you have questions or you got stuck, want me to repeat something, please let me know. Okay, mine's finished running. One thing I can do is ls-l stats star. Okay, so I want it to list all of my output files, and I want it to give the timestamp of those files as well. So I do the -l. So I can see that all the output files were just created at 11:17. So these are the new files, not the old ones that I created earlier. Okay, great. Let's go ahead and start on the exercises. And while you're working on those, if you come across any questions, you can also ask. So go to the lesson, the shell scripts lesson link that I put in the chat earlier, and then go ahead and scroll down to the first exercise that you come across, which has the pencil icon. The first one is list unique species. So go ahead and work on as many of those as you have time for. I think we could work until gosh, this lesson was pretty quick, so I think we could work until 11:30. All right, it's 11:30, so I want to move on to the next lesson, so I'll have time to complete everything. It's all right if you didn't have time to complete these exercises. I know there's actually quite a lot of them, so this link will be here indefinitely if you want to come back to it later. I'm going to go ahead and click back so that I'm on the main menu for our bash lessons, and click on finding things. That's the next lesson we're going to do. So have this open for the exercises later, please. I'll go ahead and put it into the chat. Okay, next we're going to be learning about how to search for specific text within your files and how to find files and directories in the directory tree. So I'm going to clear the screen, and we're going to cd into the writing directory. So I'll start by typing tilde, which is the home directory, and from there I want to go into shell lesson data and then writing. I use tab completion to make that a lot less typing. So everybody should be in this directory. So what we see there are a few different subdirectories and a text file called haiku.txt. So a tool that I briefly introduced earlier for searching through text files for a particular string is Grep. This stands for Global Regular Expression Print, so it's not something that's necessarily easy to remember, but if you use it enough, you will remember grep. So let's go ahead and just try it. So I want to search in the haiku.txt file for the string not, N-O-T. So I'm going to type grep. The first argument is the string that you're looking for, so not. And then the next argument is the file that I want to look in. So what grep outputs by default is each line that contains the word not. And by default, it is case sensitive, so it has to be all lowercase not. Okay, so actually, before I do this, we can actually just look at that file. Let's just do cat haiku.txt. So this is just a little haiku or a poem. It's pretty short, but we use it just for demonstrating how to search for text. So you can see that there are a few of the lines have the word not, and the grep command was able to locate just those lines and print them out. Let's do another example. So grep the with a capital T. So you can see that what it did is it found every line with the word the on it, but it did not obey word boundaries, which means that the could be part of another word by default. If we wanted to obey word boundaries and only print lines with the word the, where the is its own word, then we can use -w for word boundaries. Okay, so this time it only prints the one line where the is a separate word. I can search for multiple words by putting them in quotes. So grep -w. I'm going to search for the string is not. And it found one incident of the string is not. Let's see, I could also search for just the word it. And I can use this -n. So the -n flag will cause grep to also print the line number of each matching line that it finds. Right, so this is the line number in the file haiku.txt where it found the match. Let's see, I can combine multiple options. I didn't need the quotes in that case, but it doesn't hurt. Yeah, so this combines the -n option, which prints line numbers, and -w, which causes it to only print matches that obey word boundaries. Let's try it with an extra option. So add -n, -w, -i. So I stands for insensitive. So this makes it case insensitive. So that means the word the could be upper or lowercase, any of the letters. Okay, so this time it found the one with the uppercase T, but I said it needed to obey word boundaries, so it didn't find the match where word the was part of the word thesis. Okay, so the -v flag will invert the match, which means it prints each line that is not a match. So let's try the following. Grep -n -w -v the haiku.txt. Okay, so we've said print the line number for each one, obey word boundaries, and print only the lines without a match. So this will print only the lines that do not contain the word the, and we've not said it should be case insensitive, which means it needs to be case sensitive. So only lines that do not contain lowercase word the. Right, so you'll see it also printed the blank lines as well. Any questions so far? So you can type man grep to see the manual page for the grep command, which shows all of the different options and how to use them, and a lot of stuff that you might not even know you can do with grep. So it's nice to just peruse these man pages from time to time to see what you can do. I'm just paging down using the down arrow, and then to quit, you type Q. Okay, so the real power of grep comes from using it with complex expressions that include wildcards and a lot of other special characters. And these are what are called regular expressions, which is kind of an advanced topic. So if you want to know more about it, you can Google it and kind of learn more about it on your own. But I will do one quick example. So let's do grep-E stands for regular expression. It means that what I put into these quotes is meant to be interpreted as a regular expression. So I'm going to put into the quotes the match that I want it to look for. So I put this little up arrow dot O. So this up arrow means that the match has to be at the start of a line. And the dot is a wildcard that matches any single character. So it's like that question mark wildcard that we talked about yesterday. And then the O is just not a special character. It's just the letter O. So what this is going to do is print all of the lines that have a lowercase o as the second character in the line. So the first character is anything. That's what this wildcard stands for. The up arrow means it's at the beginning of the line. And the O is just has to be the second character on that line. Okay, so it printed out each line that had a match. Each line where a lowercase o is the second character of the line. All right, so that's just one regular expression example, but you can do even more intricate and powerful matching terms using regular expressions if you're interested in that. That pretty much covers what we have in this lesson on searching for text within files. So we're going to switch gears a little bit next and talk about how to search for a file that's in the directory tree. This can be very useful, especially if you have a very deeply nested directory tree with lots of subdirectories. So for that, we're going to use a command called find. I'm going to clear the screen first. Okay, let's do an example. So find space and then dot. So if you recall from yesterday, dot is a shortcut for our current working directory. So the first argument that you give the find command is where you want it to look for things, right? So I want it to look starting in the current directory. And what I want it to search for is anything. So I'm not going to give it any more arguments. So just find everything that's in the current directory or below. So it searches recursively throughout all of the directories that are below whatever one I provide here as the argument. Okay, so it looks in the current directory and it finds haiku, data, and then it looks inside the data directory and it finds some files in there. It finds littlewomen.txt, 2.txt, 1.txt, etc. So it just prints out everything that it finds, all the directories and files. Okay, what if I only wanted to find directories and not files? Then I would do find dot, and then I would specify the type flag, and then D for directory. So only find things of type D. Okay, so this time the output is only the directories and subdirectories. What if I only want files? I can do type F. And this will only print the files. It does show what directory the file is in, but the thing that it found is a file. Okay, let's say I don't want it to search recursively through all the directories, but just look in the current directory. I can type find dot, and then I can specify a max depth of 1. That means only look at one level in the directory tree and don't look any deeper. And then only look for files. So it only finds haiku.txt. I can likewise specify a min depth of 2, for example. That means don't look in the current directory, but only in directories below that for files. So this time it should not list the haiku.txt file, but it should list the other ones. I can also search for a file with a particular name. So let's try find dot and then dash name, and then we give it a name to look for. I want it to find everything that ends with .text. So I'm going to do star.text and see if that works. This is actually a mistake, and we'll see why in just a second. So it finds haiku.txt, but it didn't find all of these other files .text that were located in subdirectories. And the reason is that it expanded this. When the shell expands this wildcard, it expands it to everything in the current directory that ends in .text. So what I was doing was exactly this. Okay, that's what I was doing. But if I want it to not expand that until it runs the command, the find command, then I would put it in quotes. Okay, so that time it worked the way I meant for it to work. And it found all of the .text files that are in the current directory or below. Okay, so find and ls are kind of similar. You may have noticed, but find can be made to search for much more specific things. It's more flexible and has a lot more options. So let's try combining this with the word count command to find the number of lines in each of the files that I printed out here. So let's try using a pipe and see what happens. Okay, so it's the same command I had before, but then I'm piping the output into the word count command and see what it does. So what I wanted it to do was count all the lines in these files and then in each of these files and print that out. But what it really did was it just counted the lines here. So there's 4, 1, 2, 3, 4. So it just interpreted this as the lines it was supposed to count. All right, so what we need to do instead is we need to run the word count command, and for its input, we give it a list of files that's created from the find command. So if I put something in parentheses like this and put a $sign in front, the shell will first execute anything that's in the parentheses and replace it right there on the command line. Okay. Okay, so that's what I actually wanted it to do. So word count command can accept file names as arguments or lines from standard input. And when it accepts lines from standard input, it just counts those lines. But when it accepts a file name as an argument, it will count the lines in the file. And that's why, that's the difference. So in this case, here where we used a pipe, it was accepting these lines as standard input, and it just counted those lines. But what we wanted it to do was accept file names as input arguments and then count the lines in those files. So we can use this, this syntax to combine the grep and the find command together. Let's say I want to look for the string capital F, capital E, and I want to look for it in all the files the name star.pdb. So anything, I want it to start one level up from where I am now. So I want it to start in that shell listen data directory. And I want it to search recursively down through all of the directories in that main directory for any file that ends in .pdb, and look in all those files for FE and then print that out. So it looks like it found one file that contained that string. It shows the file name that it found it in, and then it prints the line that that contains that string. Any questions? Okay, it looks like we have plenty of time to hopefully complete most of the exercises in this session before noon. So I'm going to go ahead and have everybody start working on the exercises. Please open the link that I put into the chat and then scroll down till you see the first exercise. The first one is called using Grep. So let's work on that until noon. If you have any questions about these exercises or ones we already covered earlier, you can go ahead and enter those into the chat or ask them. And please, before you decide to leave, please fill out our survey that Colin just posted into the chat. This is a really quick survey that just gives us feedback. It asks questions about what we did well and what we can improve upon. So please do that before you leave, but stick around till noon so you can get through as many of the exercises as possible and ask questions while we're available to answer them.